Okay, here we have a spinner. Right, the most likely letter is going to be A. And this one, okay, I put 2 acceptable answers, 2 out of 8. So that was either 2 Bs or 1/4, simplified form. Same here, 3/8. Pretty easy. Okay, can't simplify 3/8. Next question, flying right through it. All right, so a box has 6 blue pens, 8 black pens, and 3 red pens. What's the probability that he will pick a blue pen? Well, you need to find out how many pens in total. I have 6, 8, and 3. So that's out of 17. Okay, so it's going to be 6 out of 17. Pretty sure that was almost all correct by everyone. This one, green pen. Well, there are no green pens, so it's an impossible event. 0 is the answer. All right. Some of you wrote 0 out of 17, which I marked as correct. Okay, but you could have just written a 0. Impossible. The second part was a bit harder. All right. Same box. I add some blue pens. And the new probability is a half. Okay, there are 2 ways to do this. The first way, right, was by, you could use some algebra to do this, but I don't think anyone here did that. Or you just do a guess and check method. Just try, okay? So if I have 17 pens to start with, and there are 6 blue pens, okay, 6 blue pens. So just try it. If I add 1 more blue pen, that'll be 7, 18, okay, that's not half. If I add 2 more blue pens, that's 8, and there'll be 19 total. See, I'm just doing a guess and check. That's not half either, but I'm getting close. So 1 pen plus 2 pens. Just try another one. Why don't I try plus 5 pens? Okay, so that's 11 blue. 17 plus 5 is 22. And look, 11 is half of 22. So that means in total, I added 5 pens. Right? Answer was 5. Not too many people got that one correct. But there you go. Answer was 5 pens. All right, next question. Now we get into the real stuff. Those are kind of like warm-up questions, to be honest. All right, probability trees. The probability that a bus is on time is 0.75. All right. Calculate the probability that the bus is late on both days. So late, late. So basically this one should have been on time, and this one should have been late. Okay, on time and late. So on time, late. So on time is 0.75. If this was 0.75, what would the probability of it being late be? Anyone? If that's 0.75, what's the probability of it being late?
0.25.
Good, Martina, 0.25, good. All right, and in fact, it would be late, late. You know what, guys, I did this the wrong way. This is late. This is on time. 0.25, 0.75. So the probability of it being late, late, okay, it's going to be, so late, late is 0.25 times 0.25, which equals 0.0625. All right, which is equal to 6.25%. So the answer was 6.25%. Some of you did the rounding wrong. You made it 62.5%. All right. Wait a second. Is that 0.75 and 0.75? Oh, no, it's not. Okay. So 6.25% was the answer. Okay. Next question. Venn diagram probability question. Okay, student liked maths. Well, this was good. So I'm working out, I saw here. You just have to add up the four numbers to find out how many students were surveyed. So what was it? 29 plus 17 is 46. 46 plus 4 is 50. Right, so number of students is out of 50. What is the probability the student liked math? So I look in the M circle, 24 plus 5 divided by 50, 29 out of 50. Okay, 29 out of 50. What is the probability that the student did not like English? Okay, did not like English. So I look at the E circle and I look outside the E circle. So 24 plus 4, 28 out of 50, which can be simplified as 14 out of 25, right? I think that was done pretty well. But the last one, a bit of confusion here. What is the probability that a student selected a single subject as their preference? Okay, only maths or only English. So you're looking at this guy and this guy. Okay, these people chose two subjects, so we don't include them. These people chose none of the subjects, so we don't include them. So it's going to be 24 plus 17 divided by 50. It's going to be 41 out of 50. Okay, just one mark each there. Very simple. This one. What is the probability the student likes maths given that he or she does not like English? You remember the given part? So that means I start with the English, given that he or she does not like English, or people who don't like English. So that means 24 plus 4. And how many of those like maths? Well, it's 24 of them. So 24 out of 28. 24 out of 28, which simplifies as these fractions. Okay. And not a lot of people got this one correct. But think about it, guys. It makes sense. 24 out of 28, that's a fairly high probability, right? Fairly high chance. And it makes sense that students who do like maths, typically they don't like English. All right? There's a high probability there. So just one mark each there, not too hard. But obviously these given ones always get a little confusing. All right, any questions so far? Cool. This table was filled in very well. Everyone got this one correct pretty much, I think. 9, 15, 60, blah, blah, blah. Okay, how many people had 20 or over driving lessons failed their driving test? So that means you have to look at 20 or over driving lessons, over 20 and fail. So this box here. It's a small number. It was 15. Okay. What fraction of people failed their driving test? So fail total would be this one. It was 2/3. Okay, simplest form. I think the answer was 60 out of 90. Yeah, 60 out of 90. This one over that one, 2/3. Alan says having 20 or over driving lessons helps a person pass their driving test. So this is what I was saying before. Some people just said he is correct because less people failed. But in these kinds of questions, you always have to give the evidence. You have to give a reason. So do an actual calculation, right? Compare the numbers use the data in the table. It's not enough just to say less people will fail. Okay, you have to say 15 people passed or 45 people failed, or you have a higher probability, blah, 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 using the calculations in the data. Okay? There's another question similar to that where you have to explain. Oh, the latter one. We'll get to that one at the end. All right, this was the doozy of a question. I chose this one on purpose, kind of challenging. All right. So Nick takes 2 apples at random from the box. He doesn't replace them. Okay, Caleb probably both of Nick's apples are bad, so that's just bad. That wasn't too bad. It was going to be, this is going to be 3 out of 10 and 2 out of 9. Okay, the denominator changes. So it becomes 6 out of 90, which you could have simplified as 2 out of 30 or 1/15. Right? Calculate that at least one of Nick's apples is good. Okay, at least one of Nick's apples is good. So that means there's several outcomes we could be aiming for. Okay, I could have gotten good, good. Okay, I could have gotten good, bad, or I could have gotten bad, good. Okay, that was the trick there. There were 3 outcomes. Some of you only calculated 2 of the outcomes and you added them. If you did that, I gave you 1 mark. All right. You just got to do them separately and then add them at the end, the 3 outcomes. Or alternatively, I could have just done bad, bad, and then 1 minus that, right? The complementary probability. All of these 3 added together are the same as 1 minus the bad, bad outcome. Okay, so the answer here was going to be 14/15, or 28/30, 84 out of 90, 42 out of 45. Okay, so there are 3 outcomes to consider there. That's the trick. That was the trick. All right, you guys being very quiet. Can I get a whoop whoop so I know you're alive?
Alive.
Okay. Thank you. Okay, this one was pretty hard. So now the box contains 8 oranges and 4 bad oranges. Sorry, 8 good oranges and 4 bad oranges. Crystal takes oranges at random from the box one at a time without replacement until she gets a good orange. Okay? Until she gets a good orange. So calculate the probability that she takes 3 oranges. Okay? So that means essentially she would have gone bad apple, sorry, bad orange, good orange. Okay? This would have been enough to draw for your probability tree. You didn't have to do every branch because it would have gotten really messy. Of course, if you did every branch, that wouldn't hurt. Helps you see the whole picture. But bad, bad, good. Essentially, you would have wanted 8 out of 12 for the first bad. Okay, the second, sorry, 4 out of 12 was for the first bad. The second bad would have been, well, there's only 3 left, and there's 11. And then,
Mr. Lu,
yes.
I just got a question about my one.
Yeah,
Why
yours
did I?
was quite nice.
I'm just confused why I only got 1 mark. Like it's not like a big deal, but it's just I want to know why.
Yeah, let me see. I remember yours. Yours was a nice tree. What page is that? 6, 7. Bum, bum, ba-da. 4 12s, 3 10s, 8 10. 4 12s, 3 11s, 8 10s. I think because you went bad, bad, bad. You multiplied bad, bad, bad. No, wait. Because you only wrote 8 tenths in the box, Natalie. You didn't multiply them together. To find
Oh, okay.
Yeah, you wrote the final one, but the tree was exactly correct. Okay. Good question. Worth asking, always worth asking, guys. Okay, so don't forget, you have to multiply along the branches. And that was the end of the probability section. Okay, not too bad. Now we move on to some trig / Pythagoras. Okay, so page 9. Page 9. Find the length of the side RT in the triangle above. Okay, so here's RT. This was worth 3 marks. Now, you have a 90-degree angle and you have a 53. So this is the hypotenuse, right? And this is the reference angle. So that means I have this guy is opposite and this guy is adjacent. And we're trying to find adjacent. Okay, we're trying to find the adjacent. So that means OR, I'm going to use tan, right? So tan 53 has to equal opposite over adjacent. 14, let's call it X. Now, some of you, or most of you, got the tan correct. You identified the right trig function. However, in the calculation, you did X equals 14 times tan 53. When in fact, there's a bit of sneaky algebra you need to do because look, the X is in the denominator, which means I have to multiply both sides by X to get it out of the denominator first. All right, so X times tan 53 equals 14. And I need to divide both sides by tan 53. So it's not multiplied to get X, it's going to be divide. All right, I gave you a mark for identifying tan, and then another 2 marks for solving the rest of the equation properly. So X was not, I think you wrote 10 point something, but the answer was, no, sorry, the answer was 10 point something. Some of you wrote 17 point something, I think. Right, 10.5, 10.55. It was a divide question. But you identified tan correctly. I think someone did a cosine by accident. You identified adjacent properly, but that's the hypotenuse. We don't have the hypotenuse. We only have the opposite. Okay, cool. The latter question. All right, we're trying to find the angle. Okay, trying to find the angle. All right, so tan of, let's call it alpha, equals opposite over adjacent. So 5.8 divided by 1.5, which means alpha is just the inverse tan of that ratio. Calculate a question. Now, some of you just wrote yes in the box without any evidence to support it, without any calculations. You were meant to say yes because if you do the working out, it's something like 75.5 degrees, I think, which is in the safe range of 70 and 80 degrees. All right, so you had to show the working out. All right, it's not explicitly stated, but you should have done some working out anyway. Okay? So again, it's based on tan because opposite versus adjacent. And then to find the length of the ladder, you just use Pythagoras. That was a simple one. Okay, Pythagoras would have given you 6 meters, roughly. Okay, 6 meters, 5.99. Which makes sense, right? If you think physically, if the ladder is about 5.8 meters up the wall, well, it should be about 6 meters in length. Okay. Nice. Almost at the end of the paper. All right, this one was fairly simple again, but putting it in a real world 2D example. I even drew you the diagram. Okay, 10 miles east, 8 miles north. So all you have to do again is the Pythagoras problem. It's going to be 10. This is going to be 8. That's Bristol. You're trying to find the hypotenuse, right? So the hypotenuse is going to be 12.8 something. Okay. Again, if it's the hypotenuse you're looking for, it should be the longest side in the triangle. Okay, that's always a good thing to check. If you calculate the hypotenuse and you find that it's shorter than the other 2 sides, you did something wrong. And sneaky little bearing question. Someone wrote here, I forgot bearings. That's okay, it happens. I have a working out here. What you want to do, I'll just do it on this page. You want to find the bearing of the helicopter from Bristol. So you're standing at Bristol. Okay, you're standing at Bristol. The helicopter from Bristol. Oh, hold on a second. I did the bearing of Bristol from the helicopter. Oh, bugger. That should be okay. Let's see. If that's 8, that's 10. Whoops. This angle is what we're looking for. That's going to be 90. North line. Okay, bearing is from the north line, remember? So if I find this angle, I can find this angle. So it's just going to be an inverse tan of 8 over 10 to find the inside angle. Oops. Inverse tan of 8 over 10. Inverse tan of 8 over 10. 38.7 degrees. Okay. If this inside angle is 38.7 degrees, I just do 90 minus that to find the answer. Boom, boom, boom. 51.3 degrees is the bearing. Did anyone write 51 degrees and I marked it wrong? Let me have a quick look. Page 10. Ba, 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 ba. Oops. No one? Okay. It doesn't affect anyone's marks. I noticed towards the end of the paper, people were running out of time. Oh, 38.6. Oh, okay. I can see some extra marks I can add on here. Jan gets an extra mark. All right, if I marked you correct, I'll leave it there. 12.8. All right, I'll double check that page 10 for everyone because I marked it wrong. But from memory, I don't think many people gave it a good go anyway. Yep, Martina gets an extra 1 or 2 marks as well. Good job, guys. Okay, only 2 pages left. Thank you for paying attention. Slide 11, where are we? Oh yeah, algebra. This was probably the easiest section besides the fraction one at the end. Where is it? Here it is. Okay, we got to expand this. So 5x minus 10 equals 35. Some people had a plus 10 here or something like that. So we add 10 to both sides. I get 5x equals 45, not 25, which means x equals 9. Okay, x is 9 for that one. Now I have variables on both sides. I'm going to subtract 6y from both sides. So 3y equals 12, y equals 4. Right, y equals 4 here. Easy peasy lemon squeezy. And then the last page. Factorize fully. This was almost done correctly by everyone. The e goes out the front. You put a 2 there. You put an e here. Ta-da! Okay, some people did this, which is totally fine as well. All right, this one, some people only factorized halfway. They maybe pulled out the 6 in the front, 2x plus 3x squared, right? But as you can see, there's still an x in here and an x in here. So I can factorize it fully. The answer is 6x outside of 2 plus 3x. That's the full answer there. All right? So 6x outside of 2 plus 3x. All right, expansion and simplification here. Nothing really here to go over, but for you to practice your FOIL. I saw some working out on people submitted scans, which is very nice, drawing the arrows. The only trick here was with the plus and minus signs. Yeah. So the answer here was x squared, x squared plus 3x minus 18. So plus 3x minus 18. And this one was x squared minus 13x plus 22. Okay, minus 13x plus 22. And lucky last, some algebraic fractions. This one had a fraction answer, which wasn't very nice. I multiply 8 over here, so I get 16 over 5 equals 3x. On x by itself, so I divide by 3, so x equals 16 over 15. Sorry for that ugly answer, but why not? See, 16 over 15. And this one was a doozy. All right. You got to make this a single fraction. So you multiply by 3 and by 2. So I get 3 outside of x plus 5 on the left-hand fraction minus 2 outside of x minus 2 all over 6, which equals 4x over 5. All right, so I can simplify the top here. That becomes 3x plus 15 minus 2x plus 4 all over 6. Okay, which equals 4x over 5. These two can be simplified. So it becomes x plus 19 divided by 6 equals 4x over 5. Okay, this was a hard one, but they can't all be easy. Dot, 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 times by 6 times by 5, collect like terms. The final answer is 5. Beautiful. Okay. I was very impressed. A few of you got that one out very well. That was very good. Okay, but then a few of you got this one these really easy ones wrong. So I was like, wow. All right, and there you have it. That was the whole paper. All right. Any questions on that? Is there anything you want me to look at your test again if you think I marked wrong or I misunderstood your answer or you're working out maybe? All right, good. If not, let me know. What do you think? That is, a pretty good example of a core assessment. I feel like many of you did much better than you have in the past, and that's kind of what we expected. All right. Give me your feedback. What do you reckon? Was it a good idea to go into the core?
I think it was a pretty easy test.
Pretty easy test?
Yeah, like it wasn't like to the point where I can't I don't know about the other people, but I remember when I was in the other class, like I felt like I couldn't answer half the questions and I felt really stressed about it.
Yep.
While here, I felt like even if the question was a little bit hard, I could still show some kind of knowledge, and most of them were pretty like doable.
Yeah, good. That's exactly what it's designed for. So that's good, Jan, that you felt that way. That you knew at least something to start, right? The question off. Very good. Now, this is not obviously the full, level of difficulty as a mock exam or something, but it was a good taster for it. Anyone else have feedback similar to Jan? That's good feedback.
Yeah, I feel the same, or at least that I knew that when I was finished with the test, I just felt like I've written most of it and it wasn't like I left anything out. Like I always knew at least something from the question, which didn't really happen to me when I was in the extended. Like usually I was just like
completely lost.
Yeah.
Good. Okay, so that's very good. I'm glad that we feel like that. And from the results that I saw, right, like it wasn't surprising. Like no one got like 100%, right, which means that it wasn't like super easy. But no one was getting D's or E's or F's as some of us were previously. Okay, so that's good. And even if you got a D this time around, that's an improvement from where we were last time, I believe. And that's what we want. We just want slow improvement. Okay. So tomorrow we will look at another past paper together. We might even do an investigation paper, not an exam paper, a core paper, but an investigation one. If you remember those investigation ones, they're a little bit different. And it's kind of a good way to do a Friday class, or Friday afternoon class anyway. Okay, so I'll have a look again at that question 10. It might bump one or two of you up a few marks, but not too many marks. But other than that, very well done. I'm happy with how that went. And we'll have to, as Vojta referenced before, continue collecting some more pieces of evidence from you. Some of you may receive an email from the Maths department about old stuff that you have. What is the probability of us asking you to find a test from like term 1, 2019 or 2020. Do you guys keep your old notes, your old papers?
Not really.
Yeah, that's what we thought. Right.
I actually have all of my notes.
Yay, good, Natalie. Okay.
I mean,
So,
it's not like I look back at them, but you know.
yeah. So some of you, we may ask you to bring in some tests from like the year 10. So if you have some spare time and you have nothing to do, you're trying to organize yourselves, try and find your old math stuff and get some of it ready. If you remember, right, if you specifically remember you did really well at the beginning of last year, I know some of you did, we looked through the results from last year. If you got some B's or C's or A's even, try and find those tests, okay? If not, then that's okay. We'll continue making these tests up for you. All right. Thanks, guys. Have a great day. I'll see you tomorrow.
Thank you, Mr. Liu.
Thank you.
Bye-bye.
Bye. Have a nice day.
Bye, Mr. Liu. Thank you.
Ciao, ciao.